So today we are talking about similar figures. And here's kind of a definition of similar figures. Similar figures have the same shape, but are not necessarily the same size. And the length of the corresponding sides are proportional to one another, and also the corresponding angles are congruent. So there's a lot of math words there, but basically what's going on is if you have two shapes that are the same shape, just different size, then they're probably going to be similar. And if they're similar, then the sides are proportional. And in the last lesson, we just talked about proportional, where you can set up two fractions that are equal to each other. Oops, thought I was writing. Two fractions that are equal to each other, and then you can cross multiply. If it is a proportion, you can set up the fractions and cross multiply. And now we're just adding on and we're saying that these are similar figures, and because they are similar figures, the sides have to be proportional. So we're going to be able to use that to find some missing side lengths and to be able to tell whether figures are similar or not. So let's kind of jump right in. What is the ratio of the measure of side BC to side RS in simplest form? All right, so we want to do BC over RS. Remember, whenever it gives you a ratio, you can set it up as a fraction. So BC is 6. RS is 24, and it wants this in simplest form. So you have to reduce the fraction. Now for some of you, you can look at that and say, oh, I can divide each by 6, and you can reduce it that way. For some of us, we're going to want to use our calculator. Remember, calculators can reduce for you, so you're going to do 6 divided by 24. We don't want our answer as a decimal. We want it as a fraction, so we're going to hit this blue fraction button, and that reduces it for us to 1/4. So this ratio of BC to RS would reduce to 1/4. Determine whether the pair of figures is similar or not, and explain your reasoning. Okay, so we just talked about in order for them to be similar, all the angles, corresponding angles, have to be congruent, which congruent is just a fancy math word for equal. But if you look here, all of our angles are right angles. They're all 90 degrees. So the angles work out. So then we have to check the side lengths. For it to be similar, the corresponding sides have to be proportional. So we're going to set up some fractions and we're going to cross multiply to see if they are proportional. All right, so I'm just going to pick any two numbers. I'm going to do, well, since it's a rectangle, we only have two numbers on each, two unique numbers. So I'm going to do 15 and 8. Now, when I set up my first fraction, I'm going to set it up. It doesn't matter how I set it up. Honestly, it could be 15 over 8 or 8 over 15. It truly does not matter. So I'm just going to do 8 over 15. But then I have to be really careful that my second fraction matches it. So 8 was this little piece right here. So when I go to my second rectangle, I need to make sure that I use that little piece right there on top. And then 15 was this long piece, so I need to make sure that I use this long piece and put 7.5 on bottom. It doesn't matter how you set up your first fraction, but your second fraction has to match it. And now let's cross multiply and see if they're equal. So we're going to do 15 times 4. That's 60. And we're going to also do 8 times 7.5. I guess I'll use parentheses. So I'm going to go over here to my calculator and type in 8 times 7.5. That also equals 60. So since they are equal, then they are proportional, which means they are similar. So we know that yes, they are similar. So let's cross out the no ones, and then let's look at our two yes options. Yes, they are similar because they are both rectangles. That's not enough information. Just because it's two rectangles does not mean that they're similar. Then you could say, yes, they are similar because they have proportional side lengths and equal angle measures. Ding, ding, ding. That has both. They have to have equal angle measures and they have to have proportional side lengths. All right, use a proportion to find the missing side length of the following similar triangles. So in this case, it tells us that they're similar. So we already know that the corresponding angles are equal, and we already know that the corresponding sides are proportional. So we can go ahead and set up a proportion because we know they're similar, so we know it'll work. So remember, I keep saying when we set up our proportion, it doesn't matter how we set up our first fraction. It doesn't matter. I like to use, I'll just use the first figure here. It doesn't matter if it's 3/4 or 4/3. It truly doesn't matter. All that matters is when you write your second fraction, you get the corresponding sides or the sides that match up. So if I used 3 first, I need to look at my other triangle and pick the corresponding side, which would be x. And then on the bottom, I did 4 on the bottom, so I need to make sure that I pick the corresponding side, which would be 9. I don't really know why I changed the color there. Sorry about that, but whatever. We'll change that color too. Okay, and then we're going to cross multiply to solve for x. So I'm going to do 4 times x equals 3 times 9. And remember, our 2 steps for solving proportions is you cross multiply and then you divide. So let's do 3 times 9. 3 times 9 equals 27. And then we would divide by 4. Oops, go away. Go away. Okay, 4x equals 27. And when you get really good at this, you could probably do it all in your calculator in kind of one go. And I'll show you what I mean by that. If you do 3 times 9, then you know you have to take that answer and divide it by 4. So our answer here is 6.75. So x equals 6.75. So use a proportion to find the length of the missing side of the following similar triangles. So again, it already tells us they're similar. So we already know that the corresponding angles are equal, and we already know that the corresponding sides are proportional. And remember that word proportional means we can set up 2 fractions that are equal to each other. So let's go ahead and set up 2 fractions. For my first fraction, it does not matter what I use. I'm just going to pick this first triangle, and I'm going to do 14/8. Truly does not matter for the first fraction, but the second fraction has to match. So since I did 14 on top, 14 is the hypotenuse or the diagonal, so I need to make sure that I put x on top of the second fraction. And then since I did 8 on the bottom, 8 is this horizontal piece, so I need to make sure that I do 22 on the bottom. So I keep trying to stress this, but I really want to make it obvious. The first fraction does not matter. All that matters is that your second fraction matches the first. Okay, and then we're going to go ahead and cross multiply and divide. So I'm going to show you how when you get the hang of it, you can kind of do it in your calculator in one step. You could cross multiply 14 times 22. Get your answer, and then divide by this other number. So 308 divided by 8. And our final answer would be 38.5. Now, if you're just looking at me like, I have no idea what you just did, let me go ahead and show you. I cross multiplied. So I did 8 times x equals 14 times 22. I calculated 14 times 22 in the calculator. And then I know I got to get x by itself. Since I'm multiplying, the opposite is to divide. So x equals 38.5. Use a proportion to find the missing side length of the following similar figures. Again, they tell us it's similar, so we know the corresponding angles are congruent, and we know the corresponding sides are proportional. So let's just set up a first fraction. I always like to use my first figure for my first fraction, so I'm going to set up a fraction 10/8. Now, when I set up my second fraction, I just have to make sure that they go together. So since 10 was the hypotenuse or the diagonal side, I need to make sure that x goes on top of my second fraction. And then since 8 was the horizontal line, I need to make sure that 4, which is the horizontal line, goes on the bottom. And then we can cross multiply to solve for x. So I'm going to get 8 times x equals 10 times 4. So 8 times x equals 40. Divide by 8. And x equals 5. Let me double check all my work in my calculator. So I'm going to do 10 times 4 is 40. And then I'm going to do 40 divided by 8 is 5. So that is the correct answer. And that's it. Good luck on this quick check.